Hello everyone. So this video is more about explaining what KMP algorithm, how it is implemented, and more importantly how to create LPS array. Uh, um, just a disclaimer that this video I'm making primarily for myself, as in I'm making it to, if so in future if I want to revise the concept of KMP algorithm or how it is implemented, I can come to this video and see it and revise it. One more thing, I found lots of videos, and I've watched lots of videos. I've watched read couple of articles explaining KMP algorithm, and there was only one condition which I was not able to digest properly or understand. So this video is to for me to revise or not waste another 2 to 3 days of mine in understanding KMP algorithm. So if this video makes sense to you, okay, and if does not, you're free to skip. So yeah, so let's understand what KMP algorithm is, and before that let's understand how to create LPS array. So LPS is longest prefix suffix. Okay, and what is this longest prefix suffix? For example, let's take a string A B C A B. Okay, and now I want to write all the prefix substrings. Substrings which are starting from prefix and should not end with suffix. So proper prefix suffix, prefix substring, which is going to be A B, A B C, A B A. Correct? And all these similarly suffix substring, the substring which are going to start from the and should not end with the first character. So suffix substring. So it is going to be B, A B, C A B, B C A B. So can you see any string which is common here? I see one string which is A B. So I can say this is the longest prefix suffix substring. So we have to come up with a way of finding LPS at for every substring actually. So so yes, let's drill down to that. So for example, I have let's say I have an example called onions. Okay, and I'm going to create a LPS array. 0 1 2 3 4 5. Okay, now what I'm going to do, let's assume, now suppose this is, I have only character A in a string. Can it be a prefix substring or can it be a suffix substring? It cannot, because I've told you we cannot, for a prefix substring I cannot include the suffix, the last character. For a suffix substring I cannot include the first character. So this, for a single character there is no LPS or longest or prefix suffix string. So I can write for single character, it is the longest prefix suffix LPS is always going to be 0. Okay, now suppose I have a string called ON. So here can I say I'll be comparing, and now I have a string, I have I'm finished with this string. Now I have a string dot ON. So what I'm going to do, I'm simply really sorry if you hear the background noise, it is because of my cat playing with the ball. So yes, so suppose my next string is N. So what I'm going to do, what we did here, what I'm going to do, I'm going to compare my next string. So this is my next string, suppose next string is N. So the length of the longest substring is until here is 0 and I is 1 now. Okay, so I'm going to compare string this index with the last string. Okay, so N is equals to 0. Just try to just stick to the video, you'll understand. If you'll understand, I mean you may understand it better. So yes, mm, is n matching with a? No, so I'll simply mark it as 0. Is I matching with 0? Length is 0. I is again moved to this. I matching with 0? No. Is 0 matching with 0? We have found one match. 0. I is now what? I is 3. Okay, 0 1 2 3. So A of length matches with A of I, which is O matches with O. Now what does this mean? If I have a string like this, now suppose I have a string like this. Can you see I have a suffix O and I have a prefix O? They are matching, which means I have a prefix suffix LPS of length 1. Okay, then I have then I'll increase the length to 1. Then I'm going to match what? I have already matched here to here. Okay, so if I move to the next character, what should I match this and again with O? It does not make sense, right? I'm going to match n with the next character. Okay, so it is going to be n is matched with n. And simply understand this length is also can be called as the pointer for the next character to match against. Okay, so now my length is 1. So I should match I with which character? First character. So I'm matching with first character. N is equals to n. So I'll simply increase the length to 2 or mark it as here. Okay. Then I'll move my I to here. I have come here from here. I'll move here. Now I'm going to do what? I am going to compare S with my length. Length is actually mentioning what is. It is telling me which character to match it against at the index of that character. So I have to match with the index at second character, which is O. Is O matching with S matching with O? No, it is not matching. So O is not matching with S. Then what to do? So what we can do, we can simply do we can simply move back. Simply move back, right? So if we move back, for example, if we can simply move back, right? And if we are moving back means we are comparing S against I. So we are comparing S against I and they are not matching. So what I can do? I can match S with the previous characters. Okay, so I'll do what? This is J. So I'll do what? I minus. So I will become I minus 1. Okay, this I have understood that I have to match with the previous characters. But I is this. Now I'll move to this. I'll move here. But I have one more thing here. Here my LPS is telling me what character. I have already figured out here as in what next characters I have to match against. Right? So it is already telling me that LPS of I is telling me which next character to match. So if I go to I minus 1, which is 2 minus 1 is 1, LPS of 1 is telling me that I have to match against 0 now. So I will become LPS of I minus 1. So it is telling me I have to match with 0. Is S equals to 0? No. So it is length is equals to 0. Correct? So I think, even I did not understand this for some time, like for days. But let's just stick to this and then let me come up with one more example. And there you might understand because that example also helped me understanding the concept. So for example, let's take an example of let's say an example is let's say example is I have a string called onion, onions, okay, and I have another string called onion, onions. So I have to match onions with onion. What I'm going to do, I'm simply going to match with this, match this with this, this with this. Let's say this is I and this is J, okay, and this with this is matching with this. And so what I'm doing, if AI, so let's say this is text and this is pattern. So what I'm going to do, I'm pattern if text of I matches with pattern of J, what I'm going to do, I'm simply move ahead. Correct? So O is matching with O, N, N, I, O, O, N, N. So until now I is 0, 1, 2, 3, 4, 5. I is 5 here. Okay, I is 5 here. So here as well 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so S is not matched, it is not matching with O here. So what I'm going to do, so A of 5 is not matching with, text of 5 is matching with pattern of 5. So I have to figure out what next character I can match in the previous string. I can either start from fresh scratch. So let's see if I'm going to start from I can either start from scratch, right? So I can start from scratch. Okay, and next also I can do is let's say it is this string. This, then it is the example is going to make sense. Sorry, you did not see that. So I have text here as onion, onion, ions on, or onion. So I was trying to tell you that all the characters are matching. This is matching, this is matching, this is matching, this is matching. S is not matched against I. S is not matching with I. So what I'm going to do, 7, 8, 9, 10. Yes, S is not matching against I. So what is going to happen? What we can do? We can do one thing here. This S is not matching I. So what I can do? I can start. So what we have understood, this is not matching this. So what I have to do, simple. If it would be a naive approach, we'll simply move back and match it against any character in the previous substrings. Okay, so we can match it against O, we can match it against O, right? Which is the first character, so if I match I with O, let me write it. O, I'll match it with O. So what I did, I assigned J to 0 because J is not matching with I. So I made J 0. Now J is this pointing to O and I, O and S, and I is pointing to itself. Now I'm matching. I is matched O? No. So what I'm going to do, again I'll keep at 0 only. It is at 0. So I cannot move back, right? So it is at 0 only. Then I am going to have match it against O, matched, and matched, again not matched. I'll move to O, matched, matched, matched. What is happening here? If you see, I have missed a possible match, which is O, N, I, O, N, IONSON. This match I have missed, right? Because what I did, when it was not, S was not matching against I moved back to the first character. So it is obviously not correct. So we have to come up with something different in case if text of I is not going to match a pattern of J. We have to come up with a better thing, a better approach. So the better approach could be, we have understood that we have to move back. Okay. Can't be the first character. Okay. Then what else can we do? If you see, we have if you see in this example we were discussing, we have had this, I mean we made this LPS, right? So I am gonna write LPS here. It is going to be 0 0 0 1 2 0 0 1 2 3 4 5. Okay. So if you see, we had this LPS, and how it is going to help us now. You see, we are at this index S was not matching against I, right? So what we can do, I'll simply move back. Move back means I'll do J is equals to J minus 1. So now J is 4. Now if you see, I was matching this I with S, okay, and I have come up until this, which is J0 ONION 0 1 2 3 4. Here I have come here, and now until this I see one thing. In the LPS I see that, sorry, in the LPS I have written LPS here. In the LPS I see at 4th index it is telling me that the next character I should match is the second character, correct? So I can simply get this value, that J is going to be LPS of J minus 1. Why? I am moving back, and in the moving back process it is telling me, LPS is telling me what to match the next character, which character I should match the next. If it is telling me second character I have to match next, and if you see, if I match the second character O and I, so if I match the second character I with the I, it is going to match I with the I, O with the O, N with the N, S with the S, correct? So which means I am not going to miss. So how it has helped me? It has helped me. So this is all about KMP algorithm actually. So this has helped me in telling me how to save my, or first how to move back, and how to save my matched, or how to use my already matched strings, or how to save matching those characters again and again. So if you see ONION IONSON, and I was here, this was not matching. So what I did, we could start with 0, but we saw that it was of no use. Otherwise we would have missed this match, otherwise this correct match. So what we can do, we moved back to the previous index. So J was 5 here, we went back J5, and here in the LPS we saw until here 2 strings already match with the starting. So what we can, with this help, we know that if these 2 strings are already in the, so this ON is already at the back, they're already at the back, and they're already, everything has matched until here, right? So I can simply match this I with the next I, right? Because this, if the entire thing is matched until here, I know at the back ON is repeating, which is there in the front also. So this ON, I can simply move that to the 3rd string, because they are in the back also after this. So they are obviously going to match, right? So LPS is telling me which next character I have to match. With the help of longest prefix suffix, I am getting to know which next character I have to match. So in case of not matching or failure, I'll go to the LPS and check out which next character I have to match. With this, I'll be saved with matching those characters again and again, or reusing the matched process, right? So with this, I'll simply go. Yeah, I'll simply go. I'll move here ONIONIONSON. So I'll move ON and I'll match this. So I have moved. See, these two are matching. This is what LPS is telling me, that until the previous string there are two characters that are already matched. Why to match them again? So I'll move to the next character that I have to match through the LPS, and this is it. And if you remember, this is exactly what I did when I was calculating the LPS. When I was calculating the LPS, I did exactly the same thing, right? The same thing is in case of failure, but the only difference is here we are doing it with two arrays. Here I am doing it with one array. So that is why it is a little trickier. So here you can imagine that we have to, in case of failure, that is the only trickiest condition. In case of failure, if things are not matching, in case of failure, for example, if things are not matching, IS was not matching. So what I can do, I can utilize my LPS. I'll move back. Okay, I'll move back to, for example, I was matching against I. So length here was 2. So I'll move back. Then length would have become 1. So I'll move back and then check which is the next character I can match. And I'll use then LPS for that. That's what I did. LPS is equals to length minus 1 and the length become this. Okay, one more condition and then I'll wrap up this algorithm. Another condition is that if I is 0, I cannot obviously go back, right? Like the LPS calculation. So I'll simply mark as, I'll simply move the I plus plus, because they are not matching against. If a character is not matching with the first character, I'll simply match the next character, right? Because I have no option. So I know it is a little messed up. You would find better videos, but this is again for me to help me understand the algorithm in future. I'll add few links that helped me in understanding this algorithm. I know it is very tricky algorithm. So if you want, you can check out those in the description. And yeah, again, to wrap up before wrapping up the video, just focus on or treat LPS as which next character I have to match. That's it. That's the gist of the whole trickiest thing of KMP algorithm. And one more thing, time complexity. Time complexity is order of n I am taking to create the LPS, right? And then order of m. Suppose n is the length of pattern, m is the length of text. So order of n plus n I am taking for n for creating LPS, m for searching, which is, and so total will be n plus m. And space complexity, I'm using n for creating LPS array. Okay, so yeah, thank you.